Hey, Adrian. Hello.
Okay. Can you see me now?
Yeah, I can. How are you?
All right. This is my first time trying this. Okay. Now, this how do this work? I ask you questions.
Yep, that's it.
Uh,
It looks like you're the only person in the meeting, so I'm all yours.
you
So
all mine. Okay, I got a couple
you,
questions.
you, you've got one-on-one tutoring.
Can you see me now?
Yeah, I can see you. I can see you. I can hear you. So,
Okay. My one of my questions is, how can I tell a true or false on that hypothesis test? When you on a claim. Let me pull a chair up. I'm sorry.
that's okay.
On a
Take your
claim.
time. Yeah.
Can you hear me?
Yeah, and that's better. I can hear you, and now I can actually see you a little bit better. So,
Okay, so how can I tell a true or false? When I had a problem with doing that hypothesis, and when I solve, when I say I reject the hypothesis, but on homework it actually true or false, and that kind of throws me off.
okay. Do you have a specific problem that we could look at together?
Want me a problem?
Yes.
How you want me to show you that problem?
Well, if you could just tell me, like, if it's a particular homework problem,
Okay,
we could
give
look
me
at
one
it
second.
together.
Okay. Can we do you want to do this week or last week? Doesn't matter.
Adrian, it is up to you. We'll do whatever you want. So if you want to
Okay.
do this week, we can.
Uh, Let me go back to one last week. Sorry. Let me make sure I got the right one. Okay. It was chapter 9, question number 4.
Okay, chapter 9. Which section are you working in, Adrian?
Okay, I'm looking at maybe the question was, can we go back? I didn't expect this. The Z test. I'm gonna do a Z test. Man. Okay, we're gonna go to section 9.3.
9-3. Okay.
Was put some of this down. A God.
9-3, and you said
Okay, I found this question now. Okay, it was where I'm on 2. Okay, it said test the result. Okay, it was a DVD Each student assigned a novel to read, different ones to watch. With they gave you a list of books between the books and the DVDs, and it's alpha was 0.05.
Okay, I think I see the problem. This is about the retention test scores.
Say that again.
This is the problem about the retention test scores. Is that are we on the same problem? Where it says a sample of non-English majors at a selected college was used in a study to see if the student retained more.
What number are you on? I'll find that one.
I'm sorry?
What number are you on?
Oh, well, I was just trying to make sure I was on the same number as you. So I'm looking at 9.3. The problem is about reading a book or watching a DVD. Is that the same problem?
A book or DVD?
Yes.
Yeah.
Yeah. Yeah.
I'm looking at too.
Mm-hmm.
Okay. Now the critical value was what, 1.943.
How did you find that?
What did you get on that critical? That homework already turned in.
So the critical value of you said 1.93. So that's based on alpha, which is in this case 0.05. Now
Right.
we would, in order to find the critical value, first of all, we should decide the type of test that we're doing. Is this a Z test where we'll use the standard normal distribution, or is this a T test where we'll use the student's T value? Do you know which one of those is appropriate here?
Well, see, my question is, say for example, what I did, it wasn't enough evidence. It wasn't enough evidence for that problem. So I did not reject the null, but they asked for true or false. Now, how you go about answering it if it was true or false?
Adrian, give me. Let me actually look. I'm not sure about the true or false part. Give me 1 second. I'm going to look in our course at the homework and see if I can understand better what the true or false part is. Give me just 1 second, please.
Okay. See, like it's like when you put your answer on a computer, he always, what was it, a claim is true or was a claim false?
Or whether the claim is true or false. Okay, I think I understand then. All right, Adrian, let's back up a minute then.
Say again.
Oh, I think I understand now. Okay, so let's back up a minute. It's just you and me, and we've got the whole time to ourselves. So, just indulge me. Let's just do this whole problem from start to finish, and then we'll. I think that'll help make sense of.
Let me see. Can I turn my volume up a little more?
Okay.
Okay.
Okay. So let's just go back to the beginning.
You want to bring the book out?
And I want to just, because I may be working out of an older edition, I want to just make sure that we're on the same page with the data that we're using. So give me just 1 second, and I'm copying this down, what I have, and then I'm going to show it to you.
Okay.
Can you see this?
Raise it up a little more. Okay, let me see. Yeah.
Is that the same data that you have?
Yeah. That's the one. That's the right one.
Okay, all right. Okay, I just wanted to make sure. Okay, so Adrian, in any hypothesis test, the first step is going to be to, clearly state the two opposing hypotheses. So in this case, give me just a second. They're asking, the claim is that the book scores are higher than the DVD scores. So can you tell me what you think the null and alternative hypotheses are for this test?
What I came up with?
Yes, just for the hypotheses.
It's supposed to be greater than 0. But the critical value I came up with was, for that, was 1.943.
Yes, okay. But
that's not the test value, though.
no, that wouldn't be, so that would not be the test value. Okay, so you have the critical value. Let's see, there were 1, 2, 3, 4, 5, 6, 7. There were 7 pairs here. So our degrees of freedom is 6. Let me just look.
Right.
The degrees of freedom is 6. We're using a 0.05 significance level. And you said 1.943.
That's what you got too?
Yeah, 1.943. Okay, and so now you want to find the test value.
Right.
And what's the formula that you're using for that?
I used, I started with that not D, and I found that 6.1, 6.17, 6.71. But then I went to that SD, square root of N total ZD2 minus, all that's in that square root.
Yes. Let me just put these numbers in, and then I want to make sure that I have the same numbers that you do. 90, 80, 97, 80. Okay. Okay, so what did you get for your test statistic?
Now that's good. I think mine are, if I'm not mistaken, I had a couple different ones. I want for sure, but I said T is equal to 2.81.
Yeah, that's it. That's exactly what I have. I have 2.812137, blah, 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 blah. Yeah,
Right,
yeah.
right. But now, see, and you do not, and on that one, I say you do not reject the claim.
You said do not reject?
Well, you have, now that's my thing. Now, that was way outside the critical value.
Yes. You're right, it is.
So you reject the hypothesis.
You reject the null hypothesis. So keep in mind, there are always two hypotheses. And so when you say that you reject the hypothesis, you have to be clear on which one you're rejecting. So in this case, you're right. We want to reject the null hypothesis.
Right.
Okay. And so, yeah, you're on the right. You're doing great. Okay.
Now, but this is the problem I have, because so when he don't ask for the answer, he asks, is it true or false about the claim?
Okay. I think I can now. I think I'm up to speed, Adrian. I think I can help you now. Okay. So let me show you a little picture here. So
Right.
1.94, that was our critical value.
Right.
Here's our test value. We're in the rejection region. So this is where we reject the null hypothesis. Okay, now let's look back what our null hypothesis was. The null hypothesis was that there was no difference between books and DVDs, but that's what we're rejecting. So I like to be very, visual here, and I say, I'm rejecting that. So, I'm just marking it out. So this is what I'm rejecting, is that books and DVDs are the same. Right. So, if I'm rejecting the idea that they're the same, that means that there's evidence of this other hypothesis, that that was the claim that book scores are higher. So since we're rejecting the notion that they're equal, that means there's evidence that book scores are higher. So this seems to say that claim is true. Book scores are higher.
Okay. So that would be true. The claim is true. Okay.
Yes.
Now,
yes. You got it. I'm sorry. It took me just a minute to get speed.
Let me turn around on you for one second. So say that the null hypothesis was true. So would there be a false statement? That answer could be considered false then?
That would mean so Adrian, if we did not reject the null hypothesis, then that would imply that the claim is false.
Okay. I just got reversed it. Now, can I ask you about this week's question homework?
You certainly may. Let's do it.
Okay. Oh, I got it on me. p-value. Now, that's, to me, it's kind of hard to grasp the p-value. Okay, it tells you to look between 0.05 and 0.02 to find the p-value.
Which problem are you looking at, Adrian?
Pardon me?
Can you tell me which problem you're looking at?
I'm sorry, I hear you.
Oh, I just said, can you tell me which problem you're looking at?
This is, let me see, what's this? This section 9.5. And they got this F is 2.97, and DFN is 9, and DFG is 14. It's a right tail.
Okay.
They want you to find a p-value.
Gotcha. Okay.
But you got to use table H to find them.
All right, let's look at this.
Let me get my book.
Table H. Okay, I see where we are. Let's find the p-value interval for each F test value. F is 2.97. Let me just write down a few things here. I've got to flip back and forth. Okay, and we're doing the F test. Okay, so Adrian, are you looking at table H?
Yes.
Okay, and do you see on the left hand?
Right, 0.05.
Okay, so when you look at table H, notice, on the left-hand column, that's where you're going to find the DFD. Those are the degrees of freedom in the denominator. Now, in the particular question that you asked about, the DFD is 14. And then...
Which one? Oh, 0.05?
Oh, was that the... no, I lost my place on... Is that the... yeah.
It's between 0.025 and 0.05.
Each F test value. That is 2.97. Let's see. We've got the degrees of 14 and 9. And so I'm looking, at table H, and I'm on the table where alpha equals 0.05. I'm using these degrees of freedom, 14 and 9. And in one table, I see 2.65, which is a little below what we want. And 3.21.
Yeah.
Yeah, 3.21. Okay. Yes. So, okay, when you look in table H, yeah, it's kind of table H, is basically multiple tables, and so when you look in the various tables using the degrees of freedom in the numerator set at 9 and the denominator set at 14. For instance, when you look on the table where alpha is 0.05, if you look at that intersection, you'll find 2.65.
Yeah, I found it. I got it.
Yeah. And when you look on the table above that, where alpha is 0.025, you'll find a critical value of 3.21. Do you see that?
Yeah.
Okay, so the particular F value that we're interested in is 2.97. Now, 2.97 is in between 2.65 and 3.21. And the 2.65 corresponds to alpha equals 0.05, and the 3.21 corresponds to alpha equals 0.025.
So what I got on there for my answer was 0.025 less than P, P less than 0.05.
Well, you're correct. It is less than 0.05, but can you also say what it's more than?
Say that again?
Okay, let me show you something. All right, Eric.
Yes.
So 2.65.
Yes.
Yeah.
I need to put that number there too. I didn't put that 2.65 up there though.
So here are the two values that we find in the tables. There's 2.65 and 3.21. Now, here's the value we're actually looking for. But now we don't find that value exactly, but it's in between these two values. And those correspond to 5% and 2.5%.
Okay.
I don't know exactly what this p-value is, but I know it's in between 2.5 and 5%.
Right.
So I can infer, if I were to draw a line down here, that's where my p-value would be.
Oh, that's what would be the p-value?
Yeah.
That 2.97?
No. The 2.97. Let me just.
Right. Okay.
And it corresponds to a p-value. Now,
yeah, that's what I put right here in the middle.
Yeah. So these are critical values right here on either extreme. Now, our test value is in between these two values. And that implies that our p-value is in between these two significance levels, 5% and 2.5%.
Now, I got that answer.
Okay. So all I can say is that the p-value is somewhere between 2.5 and 5%.
Okay, now one more on, now we're on the same issue, but on a question, we're on the same problem, but we got on F, question on problem F, You said F is equal to 1.65, but I
Yeah.
only came up with point 10.
Okay.
F was 0.110.
F equals 1.65 and DFN is 19 and DFD is 28. Okay, let me go back over to the tables. So 19, so 28. And 19, 2.89. That's on 0.005. Let's see. Okay. Okay, let's see. I'm gonna have to go to the very last table. 19 and 20 is oh, okay, I see. All right. All right, Adrian. I think I see what's going on here. Can you tell me like the values that you found when you look in the table? So when you go to look for that F value of 1.65, what happens? Like, can you tell me how you started and where you got stuck?
Say it again.
So it took it's that H table has so many pages. It takes a minute to look them all up. But I think I'm up to speed now. Can you tell me like where you the values that you found and where you got stuck in the problem?
Well, I can never really find it. So, cause it ain't it's not 28 on here. So you had to go down to 24. That's what I did. I went to 24.
So, Adrian, let me show you something.
Right, but it's not. It's either 30 or 24. So I went to 24, but
Okay.
I still ain't get that 6.5.
Yeah, and you know, even if you went up to 30, you're not going to find that. But notice one.
That's my whole point. I couldn't find it. So I only assumed
Okay, Adrian, let me show you this. Let's look at something together. Okay, so over here on the right-hand side, these numbers here, those are probabilities. So here's 0.005, 0.01. Shoot, it's backwards to me, but basically, let's focus here on the bottom. Here's where we have 0.1, which would correspond to 10%. Now, if you were to use the degrees of freedom in the numerator, initially I was using 20. So these values correspond to 20. But I want you to focus on the bottom line here, where we have a probability of 10%. This is with degrees of freedom of 20. This is with 24, and this is with 30. So
right.
you would find those values in a single table. Now, notice what's happening with these values. As the probabilities increase, notice in any particular column that these critical values are going down, like from 3 all the way down to 1.
Right.
And then when we go across, which corresponds to an increase in the degrees of freedom, the values are actually getting smaller again. So from 1.81 to 1.76, 1.79 to 1.76. Now, the value that we're actually looking for is 1.65. Now, 1.65, even if it doesn't matter, Adrian, actually, if we use degrees of freedom 24 or 30, 1.65 is smaller than both of those.
Right.
And notice the trend. These values are going down, and the probabilities are going up. What that tells me is that the p-value that corresponds to this f value is certainly more than 10%. Now, I don't know exactly what it is, but I know that it's more than 10%. I'm just following the trends here. So again, the tables that I was looking in, notice that the probabilities are getting bigger. They're going from 0.00 something up to just 0.1, 10%. And so the critical value that we are looking for, I know corresponds to at least 10% as far as the p-value. And so if I were going to summarize this, I would say that the p-value is greater than 10%. Now, I'm not saying that I know exactly what it is or that it's in
right.
I'm just saying it's more than 10%. And that's enough to answer this problem.
Okay.
Yeah.
Now, that's why I was getting stuck on.
Yeah, I understand. These tables are not easy to use. And you've got to look in multiple tables, and you kind of have to just kind of study the tables to see how the trends in the numbers, because in this case you're not going to find 1.65. So you just kind of have to see where things are headed, and then kind of infer, what that would mean for an F value of 1.65. So again, for a final answer, I would say, I don't know exactly what the p-value is. I just know it's more than 10%.
Now, okay, now I'm gonna jump ahead where I'm at right now.
Okay.
I'm on chapter 10, and my question is on chapter 10. I just want to make sure I got these plots right. Well, I'd have did the problem. I just need to make sure I'm comprehending this right.
Okay.
And I'm on. I'd have did. I'm going to do problem 20.
In which section?
Problem 20. I'd have did the problem. I just it's 20 on 10-1. I'm on. I think that's 10-1.
Okay.
No, let me make sure. Yeah, 20 on 10-1.
Okay, so 10-1, and I'm sorry, which problem in particular?
Huh?
I'm sorry, so I'm with you on 10.1, but which problem in 10.1?
And mine is number on the paper is number 20. It's
Number
emergency
20.
call and temperature.
Yeah, okay, I see ya. All right, so how can I help?
I mean, it's a drawn out question. It take a minute to.
So what are we supposed to do here? Draw a scatter plot, compute the value of the correlation coefficient, state the hypotheses, test the significance, and give a brief explanation of the type of relationship. Have you done part of that?
And now that's you got to do.
So let's see.
Would it help if I tell you what I got out of it?
Yes, it would.
Okay. The critical value, once you subtract it's n is 7 minus that 2, minus 2 would equal that 5. And I had to go to the back of the book, and the critical value for there was 0.05 was 0.754.
And when you say in the back of the book, which are you looking at? Table I?
Okay, table 1.
No.
And table I at the end.
Yeah. And what are you using as your degrees of freedom?
Degree of freedom. I had, what's that? Let me make sure I'm on the right one. It was 7 minus 2 was 5.
Yeah.
So, but I came up with that 0.754.
I agree. Yeah.
Now my ratio R.
Yes.
I came up with 0.1634.
Okay, give me just a minute. I'm gonna just check that number.
Yeah, because I know it's it's drawn out, because you got to do all that total of X, total Y, total,
and let's see, we've got 68, 74, 82, 88, 93, 99, and 101. And then we have 7, 4, 8, 10, 11, 9, and 13. And let's see, that. once. Okay, so I get an R value. Tell me what you had again.
0.1634.
No, well, that's not what I have. And I think that, so I think that might be the issue, Adrian. Let's back up. Tell me how you're getting that 0.1634.
What'd you get?
So I got something different. I'm not going to tell you what I got, but I want to know how you got your answer.
Well, now, what about, see, my value was, total of X was 605. Sum of Y was 62.
No, I think that's, yep. I agree.
Sum of X and Y, 5535.
Yep.
Sum X squared, 53,219.
Yep.
Sum of Y squared, 600.
Yes.
So I plugged them in the formula. Denominator was, once you did all subtractions, was 1235. That's the top number.
Now, let's see for a second. Let me just make sure. So in here we have one, two, three, four, five. There's 7 pairs here. So we've got 7 times the sum of x, y, which is 5535, and that's minus the sum of our x's times the sum of the y's, which is 62. So let me just check this. We've got 7 times 5535 minus 605 times 62. Oh, wait. 7 times 5535 minus 605 times 62. And so what did you get for the numerator?
When I get for the numerator, the top value,
Yep.
1235.
Yeah, me too. Okay. And then let's look at the denominator. 7 times sum of x squared, which is 53,219 minus the sum of x, which is 605, squared. So we take 7 times 53, 219, and we subtract 605 squared.
No, I know where I made my mistake at.
8.
You know, I know where I made my mistake at.
Okay.
I put an 8 down at the bottom instead of tying it by 7. You know, when you're with the square root, it should have been 7. I put 8 there.
Okay.
So I got that problem at the bottom.
Gotcha. So let's go ahead and just finish it out then. 7 times 600.
Give me a minute. Let me just put a 7 and remultiply that out.
Okay. Mhm.
What about 0.811?
You got it.
Okay.
Yeah.
So that's linear. So I can how can I say that? Reject the null. There's enough evidence to conclude that the linear significance of a relationship is enough. How you say that? A significant relationship in a linear. I may be saying it wrong. How would you say that?
So
There's enough evidence to conclude there is a significant relationship in a linear.
Go ahead. I'm sorry. I'm listening, but tell me again what your conclusion was.
The conclusion is there's enough evidence to conclude that there's a significant linear relationship between the two.
You got it. Yeah, that's right.
So it was R equals 0.811.
It is.
I put the wrong n value at the bottom of the denominator.
Yeah, I understand. That's a complicated formula. There's a lot of room for error there. So yeah, you had the right formula, but yeah, that was just a calculation error.
I appreciate it. I know we ran over your time limit.
That's okay.
But I'll
Adrian,
doing this more often.
Let me just show you one more thing before we go. I don't know if you did the sketch of the scatter plot, but
I pretty much got that.
Yeah, but you can kind of tell. You can imagine that there's a line that comes pretty close to most of those points. So it's not surprising to find out that there is a linear relationship. You can pretty much see it in the scatter plot.
I got that. I got that same point.
Yeah. So, when you see this picture and you can kind of imagine a line that goes between most of the points, you can expect there is a linear relationship. So you should kind of know what the result of the test would be. Now, sometimes it's going to be close where you can't really tell from the picture, but in this case, when you look at that picture, you can tell there is a linear relationship.
Thank you. Yep, I got that.
Yeah. So yeah, I'm confident that we have the right answer, really just based on the picture. And so it's a good idea to kind of make sure that you're seeing the whole connection here, how the scatter plot is related to the regression, which is related to correlation, which is related to this hypothesis test. They should all agree. So when you see a pattern in your scatter plot and it looks linear, that's what the test is about. Is there a linear relationship? Well, yeah, there is. We can see it.
Okay. I'm glad I got somebody live I can bounce questions off of.
Yeah, yes, of course. Yes, yeah, I understand. So, yeah, I think that you had the idea, but yeah, it was just a calculation error. So, really good work, because that's a complicated formula. It's easier to make a small error there. So, all right, Adrian. Well, I'm glad that you were able to join me tonight, and good luck with your homework. And I'll talk to you soon.
Okay. Thank you again.
My pleasure. Have a good night.
You too now. Bye-bye.
Bye.